Hello viewers, welcome to CUS Maths class. In this class, I'll be discussing few problems connected to trigonometry. The topic is problems based on trigonometric identities. The first question I've chosen here is to prove that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Before solving this problem, let us discuss what the prerequisite knowledge is required for solving this particular problem. Already you have learned few concepts in the previous classes that will help you to solve this problem quite easily if you recollect those concepts. What is the first prerequisite knowledge required here? The number one, I already listed 1, 2, 3. Number one, you should know the expansion of A plus B whole square. Expansion of A plus B whole square. Already you are aware the expansion of A plus B whole square. I am not going to write its formula. First you should know the expansion of A plus B whole square. Number two, trigonometric functions. Trigonometric functions and its reciprocals. In the previous class, we have already discussed sin A, cosecant A, and tan A. So for sin A, cos A, and tan A, its reciprocals are cosecant A, secant A, and cot A. That we will be using in this problem. When that condition comes, I will be explaining to you. And the third requisite knowledge is trigonometric identities. Trigonometric identities. If you are aware of these three concepts, this problem you can solve very easily. So let us take the LHS part of the given condition. What is the LHS part of given condition? Sin A plus cosecant A whole square plus cos A plus secant A whole square. So from here we have to arrive at the RHS. So as we have discussed, what you are supposed to know to solve this problem as a prerequisite knowledge, number one, expansion of A plus B whole square. So we will expand this sin A plus cosecant A whole square, which is in the form of A plus B whole square. So what do you mean by expansion of A plus B whole square is A square plus B square plus 2AB. A square means what, sir? Sin square A. What is a B square? Cosecant square A. Plus 2AB. 2 into sin A into cosecant A. So here A represents a sin A and B represents cosecant A. So sin A plus cosecant A whole square is nothing but sin square A plus cosecant square A plus 2 sin A cos A. That is A square plus B square plus 2AB. In the same way, expand cos A plus secant A whole square. So here A is cos A, B is secant A. So that is cos square A plus secant square A plus 2 cos A into secant A. 2 cos A into secant A. Okay. So here, you know the reciprocals of trigonometric functions as well as the identities. So first let us change the trigonometric functions and its reciprocal. Already we have completed expansions. Now change into the reciprocals wherever it is possible to use that reciprocals. So at the same time, I'll group sin square A plus cos square A together, because in the next step, we will use the identity. Sin square A plus cos square A. We will write it together. Plus cosecant square A. For this step, I'll write as it is. Plus 2 into sin A into cosecant A. Shall I write it as 1 by sin A? Because cosecant A and sin A, they are reciprocals to each other. Plus secant square A, because already cos square A we have written. So next secant square A I'll write as it is. plus 2 into cos A. And for cos, reciprocal is cosecant, no? So secant A can be written as 1 by cos A. Don't you see in the calculations, sin A and sin A will cancel, and cos A and cos A will cancel. Now the second, the concept that is trigonometric functions and reciprocals we have used and we have simplified. Next we are going to use the trigonometric identities. So what are the trigonometric identities you are observing in this particular calculation? Sin square A plus cos square A, already you know, this can be replaced by 1. Plus, you know that cosecant square A, 1 plus tan square A equals to secant square A, 1 plus cot square A is equal to cosecant square A. So, which is equal to 1 plus cosecant square A can be written as 1 plus cot square A plus here sin A cancels at 2 plus secant square A can be written as 1 plus tan square A plus cos and cos cancels, we got 2. So what is the sum of the numericals we got? 1 plus 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7. 7 already we got. And tan square A is also there. 7 plus tan square A plus cot square A. So check what you are supposed to prove in the given condition. Sin A plus cosecant A whole square plus cos A plus secant A whole square equals 7 plus tan square A plus cot square A. Have you seen the same answer we got it or not? So 7 plus tan square A plus cot square A is the right hand side of your given question. Therefore, we have taken LHS is equal to RHS. So we have proved the given condition. So let me take the second problem, very important problem connected to trigonometric identities. So we have to prove that cosecant theta minus cot theta whole square. Cosecant theta minus cot theta whole square is equal to 1 minus cos theta, 1 minus cos theta divided by 1 plus cos theta. So to solve this problem also, we list out the prerequisite knowledge. First, let us list out prerequisite knowledge. Okay. What is the number 1? Trigonometric functions. I'll write in short form. Trigonometric functions in terms of sin and cos. In terms of sin theta and cos theta. So converting the trigonometric functions in terms of sin theta and cos theta. This is the number 1, first concept you must know. Number 2, laws of indices. Laws of indices. Especially in this problem, we will be using a by b to the raised to the power of m, which is equal to a raised to the power of m divided by b raised to the power of m. In the calculation part, there we will discuss. Next, number 3rd one is trigonometric identities. Trigonometric identities. So these 3 concepts you must know for solving this problem. And even when I explain the problem based on these 3 concepts, it will be very, very easy for you and you can easily understand this, how to solve the problem. So let us take here also the LHS part. What is LHS here given to us? Cosecant theta minus cot theta whole square. Okay, sir. Here don't expand this a minus b whole square. Convert them in terms of sin theta and cos theta. So by converting them in terms of sin theta and cos theta, what I'm going to write? Cosecant theta can be written as 1 by sin theta, no? You know that sin and cosecant are reciprocals. Minus cot theta can be written as cos theta by sin theta whole square. Okay. So we have converted the trigonometric functions in terms of sin and cos. So both cosecant and cot are converted in terms of sine and cos. Okay. Now all of you know when two fractions are there, we can take LCM and simplify. That is sine theta is your LCM. LCM and denominator terms are same. It will become what? 1 minus cos theta whole square. Okay. So as we discussed in the prerequisite knowledge, the problem is in the form of a by b to the power of m, second law of indices. The second point is second law of indices. We will apply this formula for further calculations. Okay. So what we are going to do in the next part of the calculations, this next step it can be written as 1 minus cos theta whole square divided by sine theta whole square. Can't you write it as sine square theta? So that is, it is in the form of a by b to the power of m. That is a to the power of m by b to the power of m. Sine theta whole square can be written as sine square theta. So now what you do is 1 minus cos theta whole square can be written as 1 minus cos theta into 1 minus cos theta. A minus b whole square is a minus b into a minus b. Denominator, what we will do here? Sine square theta. According to your first identity, sine square theta plus cos square theta is equal to 1. No? There already we have discussed there are two sub formulas here. Sine square theta can be written as 1 minus cos square theta. 1 minus cos square theta, and cos square theta can be written as 1 minus sine square theta, which is suitable for this problem here. Sine square theta can be replaced by 1 minus cos square theta. That's what the third concept you are supposed to know what we have discussed in the beginning. So that is the third point also we have considered for solving this particular problem. Okay. So what is the next step of your calculation? Sine square theta, I can write it as 1 minus cos square theta. 1 minus cos square theta. Don't you see the denominator is in the form of a square minus b square? 1 can be written as 1 square. So a square minus b square is nothing but a plus b into a minus b. So that is 1 minus cos theta into 1 minus cos theta in the numerator. And denominator, I will apply this formula. A square minus b square is equal to a plus b into a minus b. Again, this algebraic identity. So 1 minus cos theta into 1 plus cos theta. So that means 1 minus cos theta and 1 minus cos theta will cancel. So what is left over for us now? Which is equal to 1 minus cos theta divided by 1 plus cos theta. Correct? Divided by 1 plus cos theta. So check, this is what we are supposed to prove, I think. That is cosecant theta minus cot theta whole square. You are supposed to prove, which is equal to 1 minus cos theta by 1 plus cos theta. So this is your RHS. We are what supposed to prove. Come back to the problem and check whether the same answer we got it or not. What is the question given to you? Cosecant theta minus cot theta whole square. You are supposed to prove 1 minus cos theta by 1 plus cos theta. So I think this problem is quite easy for you after knowing this basic concept, trigonometric functions in terms of sin theta and cos theta, the laws of indices, trigonometric identities. In fact, you can add one more point also, that is algebraic identity. A square minus b square is a plus b into a minus b. I hope all of you understood this, both the problems. So in the next class, I will come with some more good problems connected to trigonometric identities. That's all from this video. Have a good day.